Okay, so the meeting is now being recorded, and by continuing to be in this meeting, you're all consenting to be recorded. So, welcome to the third webinar of our course, Data 495, your final course for this semester, for this degree. So, getting to the exciting part of it, right? I mean, think about it. You're already in the fourth week. Wow, it feels like we just started, and you're almost so close to the middle of the course here. So again, being a small crowd here today, I'm just going to skip the next slide as soon as my slide works. I don't know why it doesn't work, but okay. So I hope you're all able to see my screen again. Now I'm going to skip the etiquettes part. Don't need that, right? Okay, we just few of us here, so we don't need to go over that. So what I want to do today is very, very briefly just touch upon one of an important aspect that I don't know if um, you know, if you found it important or if you were able to read that, but I want to kind of, stress upon a particular aspect of that was part of your readings within weeks 3 and 4, and spend most of the time on your deliverables, which is your assignment 3 and assignment 4. So kind of basically talk about your assignment in general. This is where I want to focus more of this. I mean, this session is more for that rather than coming up with content, because you are reading a lot. You have read a lot in the past courses as well. So don't want to throw in a lot again in this crunched session here. So but just as I said, I just have an aspect to talk about, and then assignment is my main focus. And then I'll go on to your questions. Okay. So with that, what I'm going to share, and again, I did share my general observation before, so I would not want to kind of go over that again. So I'm just going to skip that. But I want you to kind of look at this picture here, a nice funny cartoon, especially now you're going to get into building the machine learning model. Just just look at this picture. So is this your machine learning system? So what is this telling you about, right? It is one big aspect here is that you better know what your machine learning model is, right? What it is doing, what it is made up of, or at least know that you know how it is providing you the prediction, how it is doing the analysis. And that's why I wanted to kind of say this is kind of just getting into what I was going to talk about briefly today. It's on this white paper that has been part of your reading. And I don't know if you went in and read this paper, and it's kind of a little long, but it could be a little boring. But trust me, um, it is one of the most important pieces I could think of in your weeks 3 and 4 readings, right? I mean, you've been reading about different machine learning types and supervised model, non-supervised, and visualization techniques and all that. So maybe nothing that you probably may not have learned in the previous courses. This could be an addendum to that. But this aspect is very important piece of it. Now that you are building machine learning model for your capstone project, you're getting into very close to that. You're doing all this data exploration or your visualization technique, and what comes to the fore is, is your machine learning system going to be like that picture where you don't know why your model is doing what it is doing, right? So if you get a chance, again, if you have not read that, that's absolutely fine, but please go on and take a look at this paper. Just skim through it if you can, read through it as much as you can. But what it is bringing you into focus is that many years back, when I got into data analytics and data science, and even before that, right? This is way behind. I mean, this is not something new within the last few years. Of course, there's been a lot of progress made, but in the past, just coming up with a model was so fascinating. That's something, yes, you have all this data, you put in thousands of data and thousands of pieces of data, and it comes up with a nice prediction or it analyzes it for you. That was a wow factor. Wow, okay, you got it. You tested it accuracy, you knew that everything's working fine. You didn't have to really know much about how what output you're getting into. You're more interested in, hey, can I get to that best output? But as a data scientist, of course, what the one thing that differentiates you from just being a technologist is a data scientist not just kind of is a solution provider. A data scientist is also someone who knows what solution and what I know, what is this solution going to do, right? What is this model going to do? How is it doing it, right? You could be asked questions um, on your model. Like, think about it. Like, if you are, let's say, working for a finance company or a bank, and you're building a model that's kind of accepting or rejecting applications on loans, and then you have rejected an application, you could be questioned, right? I mean, a customer can question, hey, why is my loan rejected? And if you are in certain countries where you are legally bound to provide that answer, like in Europe, some of the laws there state that if you are probably rejecting an application or something on those lines, and if you are asked, requested, or demanded an explanation, you better provide that, right? And so your model should not be just, hey, I you can't say that I don't know how it did it, but it did it. I don't know if you recall, but there was a huge uproar on the Apple card, Apple credit card. There was someone who was in the same household, and they were in the same household, and two people, I think they were probably husband wife. I'm not 100% sure, but two people in the household, same income, similar job, everything the same. And yet, when they both applied for this card, they both got different, credit lines and a credit limit. And they put this on Twitter, X, which is now formerly called Twitter. They put it on Twitter saying, hey, what is Apple doing with this? We've got exact same credit history, job, income, everything is the same, and yet we get we get cards with two different credit limits. Can somebody explain? Can Apple explain? And trust me, Apple took this very seriously. And so again, if you are the person, you are now going to be asked by your CEO or whoever it is who's jumping on this right away because they're customers now. It could be a big, there could be a legal suit here, and they would have to explain why they rejected it. And if you, as a data scientist, there say, well, I don't know, I just built a nice deep learning model, and it just rejected this or give this credit limit to this person. You can't do that, right? You are not, as I said, just a solution provider. You are the one who is going to know the solution very well. You are the one who's going to explain that solution to anyone who demands it or who has the need to know it, right? Your leadership, so it's you moved from just explaining or communicating to your leadership or to your team, to even explaining it to the layman, to your customers, why you did or why some action was taken or certain action was taken, right? Same thing, like, if you're going to be predicting about some health issue to a person, or to say that, hey, this person has the highest chance of getting a cancer, and the doctor starts working on that, and what if the patient never have cancer in future life, and then this doctor started working on it and doing something proactively, and that could be another legal suit there. The patient could say, well, you just wasted all my money and time here by trying or treating me on something that should not have really occurred to me, or should never happen to me at all. So all these things, kind of coming into play now even more. There's been there's been a lot of talk about fairness in your model. There's a lot of talk about you know whether it is being consistent, right? Whether your model is being consistent, it's being fair. Is it what is it doing with your what's your privacy like? What is it doing with your sensitive data? All this is coming into play much more than ever before. As I said, 10 years back or 15 years back, it was more of a nice, yes, we have a tool, and as a data scientist, the techniques, but you were asked to understand these algorithms. You were asked to, as a data scientist, you have so that's one of the reasons why, again, even after the degree, when you get into this workforce, you will have to upgrade yourself. You'll have to get into knowing some of the things. Maybe you'll have to go back to thinking, oh, I learned about all these in about linear regression, about decision tree. Let me go back and brush it up. But it's going to be very, very important, because you are not, as I said, not going to get away with by saying, hey, here you go, the model is great, it's a nice random forest model I built, and in it the accuracy is 98%. Nobody's going to take that today. Well, it's fine, 98%, but explain why this and this is happening here. Why am I getting this kind of an output? You'll have to do that, right? You'll have to explain that now. So again, bringing so what's machine learning interpretability, which this paper is focused on. So there are basically two types of models, right? One is interpretable models that can be understood by human without any aids or methods. Like if you have a linear regression line, right, like a little trend, well, it's simple, right? You have a formula. You probably have a couple of variables called coefficients, and maybe the third one, the intersection and intersect. And then you can say, oh, okay, yep, this is the two variables, and this is how the output is, right? The interpretable, easily interpretable model. And then there are other models like deep learning model, or deep neural networks. They are not really that interpretable, right? You will probably not be able to but you'll not be able to interpret that well. But then there are explainable models that need additional techniques to be understood by humans. So these are the explainable models. You go from interpretable, which are like something like linear regression, to going to explainable, where you have to go to deep learning. Now, I'm not saying that they can, there are methods that you will have to use to kind of make sense out of the model, understand why did the model reject a particular loan applicant? Why did it predict cancer for this patient, or for this person, right? You will have to know that. And that's what you have to learn, those techniques, understand those techniques, that is going to make you or help you to explain this to anyone that need to be explained, right? So interpretability in machine learning is the degree to which a human can understand the cause of a decision made by a model. Now, it is crucial for trust, ethical accountability, and model improvement, as I just mentioned. So it really matters, right? I just went over why interpretability matters, right? And what is interpretability, right? It's how much we can understand and explain this model. So this paper also talks about a PDR framework, and I'll just talk about that very briefly in a couple of slides time. But just showing you, before I go to that, like as I was saying, that if you have to put this on a predictive power versus interpretability, if you're looking at that kind of two dimensions here, then you could see that and model interpretability is on the x-axis, predictive power is on the y-axis. Now, highest on the top there on the predictive power are your deep neural models, your ensemble models, your SVMs. So all those, like, they're really pretty high on predictive power and XGBoost and all that. And you know that for a fact. Then on the lower end of that scale of the predictive power could be your your classification rules, your regression models, your decision trees. Not that they are not they're not highly do not have highly predictable power. Far from that. But what I'm saying is that yes, if it is looking at a very high dimensional data, you would probably rely more on deep neural or ensemble models than rely on a decision tree or regression model, right? So that's what it is. And once you have something on a predictive power scale, the interpretability is pretty low, right? It's inversely proportional. So again, that's why it is this when you would call a deep neural model or an ensemble model that could be explainable, but they're not highly interpretable model. And the framework that I was just talking about is this PDF framework, right? It's just a yardstick for interpretability, right? Ensuring that your models are, they're accurate, they're descriptive, and they're relevant, right? It's about striking a balance between these three different critical aspects of model building. Again, I'm not going too deep into each of these aspects, but these are the things that are mentioned in the paper that you really want to go into little more details than what I'm going through. So there are some interpretability techniques, right? Now, there are model-based interpretation, which is like a built-in understanding. If you look at a linear regression model, just with like you have all the dots on X and Y dimensions, a scatter plot, and you draw a line there, you'd probably be able to interpret that very well, why that line, where it cuts through, and why it is at that particular slope there, right? It's kind of a built-in understanding. There's a formula that, hey, you have certain coefficients that you would multiply with your X variable, with your Y variable, and then you get that output, right? Or X1 and X2, and then you get a output Y. So you can really explain it. There's a built-in understanding. And then there are some that there is not much built-in understanding. You would have to come up with and you have to use some techniques to ensure that you understand that. And there are multiple of techniques there, right? So these interpretation techniques that we're talking about, it should really focus on, it should promote simplicity, modularity, and an ease of simulation, right? You should, as I said, consistency is another thing. You should be, every time you put in a certain parameter, or you put in a certain data set, right? Like if you say that one loan applicant was, rejected, the first time that you ran the model with, the second time it cannot say that it's not rejected, right? You have to be consistent. If you're passing through a certain type of, you have got certain range of values being passed as part of your data set to the model, it should give you the same result over and over again. If it is not consistent, then your model is not really a great model, right? So there's going to be, a lot of questions on this model, because it is not doing something very consistently, right? So again, there are some techniques that help you to understand. And the most in the easiest technique that you all know is visualization, right? When you have, challenges, you have high dimensional data, you make use of certain, data visualization techniques. You start with that, right? It helps you to understand the complexity of your data set, the complexity of the relationship between the data set, right? You can draw different types of charts to make sense out of your data. Like, what is your data? And right, is there is there information in the data that has been magnified for no reason? I'll tell you with the classic case, like, like you have sometimes a date field in your data set, right? And maybe that date field, and I'm assuming that date field is having that feature important, right? It's one of the features that is important in your data set. But think that with this date field, there is a weekday field, there is a day field, there is a month field, and there's a year field, right? So you have 4 other fields along with the date. Now, if date, assuming that date is a very critical field for you, what is happening here? You are you've magnified this information, and this is where you can catch some of these aspects either through using some of your visualization techniques, whether it's a scatter plot, a heat map, or bar chart, or whatever that you can use. But you use that to say, hey, if I have got a date, I don't need all these four fields, or if I have these four fields, I don't need that short date field at all. I can just delete, I can use one or the other, but I cannot just magnify this information in this data and think that, because they are so, connected to each other, they're so related to, highly related to each other, that I should use one or the other and not both, right? So again, this is where it all starts, right? And throw in, first of all, you ensure you curate your data so well that you get to a best model. And then when you create the model, then you try to interpret the model, right? This paper also talks about other techniques like, lime. Lime is one of the, very popular techniques. And guys, if you, while reading this paper, if you feel that, oh my God, this is too long, boring, okay, I understand all that, right? Go to YouTube videos, watch YouTube videos on this, right? There's lots and lots of there on the internet. You'll find many other research papers, you'll find lots of videos. If you're a visual person, it will show you what I'm kind of talking about here, or what that paper is talking about. But a very critical aspect, folks. So please do not ignore this aspect. If you have learned it before, excellent. This could be use this as a refresher. If you have not paid a lot of attention to it, then please, this is your time to pay attention, because it is this kind of techniques are going to be very useful for you when you get into the workforce, right? So one of the techniques is lime, right? As I was just saying, if a person, if you made a decision for rejecting a loan application, or telling that certain person has got a certain disease or is going to have a certain disease, then you need to have that explanation, right? And if you, let's say you used a deep learning model, and you can't just tell the patient, oh, my model is giving you, telling me that you're probably going to have a cancer, or you're probably going to have a diabetes in future, right? You got to tell the parameters, the factors why you can get that, right? What has led you to believe that this patient, that this person would get that particular disease? So again, there's something called as lime, which is, it's kind of, the technique is pretty much like, you have your model, your complex model created. This particular technique, which is called local interpretable model agnostic explanation. Model agnostic means it's a generic method that could be applied to many different modeling techniques, right? It could applied to deep learning. It could be applied to a model based on deep learning. It could be applied to model based on linear regression or decision tree. And that's why the name is model agnostic, meaning it's a generic method. Now, there are other also model-based methods like deep link for deep neural networks, or for deep learning based networks. There are some model-specific methods too. But then these techniques are going to help you to deal with multiple different methods. So what Lime does is, when you have a certain model created, it builds a surrogate model. It what it does is, like, and it's a simple, it's a package that's available in Python, by the way. If you're wondering what it is, it's not really rocket science, trust me. Once, if you see a couple of videos on how people have built this, it's super easy, guys. It's not rocket science at all. You guys are very smart, and you're going to get it right away as soon as you see it. But again, it's builds a surrogate model, and what it does, it says, okay, well, this model, I want to understand how this model is working. So it takes a sample data, and it sees, based on this sample data, if the model is going to give me this output, it learns how the model has given this particular output for certain types of data set. So it takes a sample data and it builds a simple model, which is going to be less complex. It's going to give, and it's going to be easily readable, easily interpretable. And that's how it gives you an interpretation of what your model is doing, right? And again, now you would say that, hey, you just said it takes a sample data. So how good is this surrogate model going to be, right? That could be a question in your mind. So there is something called, I believe it's called the local interpretability index. And what that is, it is saying that, hey, this index is a pretty high, it's at 80% or 70%. That means, yes, this model that you've created is 80% accurately saying what this model is doing. And that's pretty good. I mean, they can go even beyond that. But I'm just saying, in case you even question that the Lime method is accurate or not, or what you've got through that is correct, then that index is going to give you that confidence of saying, oh, okay, my index is for this surrogate model is 95%. Well, that's good. That's kind of telling me exactly what this, or very, very close to what my model is doing, right? Then there's another method called SHARP. And what this does, it basically uses a game theory, right? Like based on how much a person bets or puts their money on, what is the output like? And when they have a certain output, what is it applicable to? How much does it need to pay, do the payout to each of the people who kind of would have put in a certain type of money or input, right? It's based on a game theory. So it applies certain weightage. It sees what kind of a weightage a particular feature has. It's similar to feature importance, basically, but it gives like a kind of shape values to each of the features, and it comes up with a very simple kind of an interpretation and a kind of a visual here, which will tell you that, hey, the based on this, like if what is, if each of these features at a certain weight, they are kind of leading to a certain prediction, a prediction of class 0, a prediction of class 1. This could be, this could be loan, accepted, loan rejected, a patient has a cancer, a patient doesn't have whatever that could be, right? But then it gives you that information very easily. So it helps you to interpret your model. What has your model really paid more attention to? What has been the best features or most important features? How much of a weightage it has given to each of the features within your data set? So just something that I wanted to share with you all. Take a look at it. I've skimmed through this. I've really not done a good justice to this topic because we can go on for hours. The paper is also pretty long. You would see that, or maybe you've already read it, then you know about it. But there's a lot of good information. And if something is not that clear in the paper, as I said, please go out, research, look for videos. You'll find many. Okay. All right. Any questions? I hope this was helpful.
None so far. I guess the only thing I asked it like a little while back, and I'm glad we're talking about Lime and Shop right now. Do they fall somewhere on that spectrum, like a couple slides back of that graph that has um, predictability versus interpretability?
Yeah. So,
Where would you say? Yeah, but I think it's like the one before this one.
yep. I'm going back here.
Yeah, this one.
Right.
Where
So,
do
yeah, sorry, go ahead. Complete your question. Sorry.
Yeah, where do Lime and Shop fall in that spectrum here at
So
that
Lime and
if at
Sharp
all?
are basically interpretation techniques which could apply to pretty much any of these modeling techniques, right? You could take Lime and Sharp and say, okay, I have a model that has been created by using linear regression, or I have a model that's been created by, let's say, cluster k-means k-nearest neighbors, or with classification rules. You could apply to this, although you may probably don't need Lime to really interpret linear regression. But the point I'm trying to make is that Lime and Sharp are interpretation methods for understanding or interpreting any of the models that you build. Like they're generic methods, basically. They're not tied to a particular model technique saying, oh, okay, But there are some model-based methods also. Like as I said, there are specific modeling or interpretation techniques for deep neural networks. I believe one of them is deep link. So they are model specific. Deep link or the model specific cannot be used for another model, right? They would not work. But the Lime and Sharp are techniques that work across the board. They're very generic techniques and methods.
Okay, I mean, I guess it makes sense since it's literally local model agnostic thing, so it's supposed to be able to work across the spectrum.
Yeah, exactly. There you go. Right. Absolutely. Good question there, Chase. Any other questions? Okay, very good. So let me go on now next to talking about your assignment, right? So you've gone through, first and foremost, let me tell you that your assignments, this particular project report that you're building is a living document, right? What do I mean by that? What I mean is that as you go on to build different sections or work on your project, you're going to kind of lay it out. And let's say you started with us, as Chase was saying, he started with a particular way of working on his project. And then, oops, all of a sudden, when he was in assignment 3, maybe in the modeling part or maybe in the visualization part, he realized, oh, this is not what I want to do. Maybe this is how I want to do it, or this is what I should be really looking at. Fine. It's I mean, again, you're not gone too deeper into it. If you've gone too deep, then I don't want you to change. But then again, you could kind of go back and say, well, I found this, but I mentioned something on in my executive summary. I mentioned in my project scope, my scope has changed. Yes, you can go back and change these sections, right? So doesn't mean that, oh, at the end of your project report, when it's created, it should be a completely a logical flow, right? You're going to use this report, you can use this report when you go on to an interview and showcase this. You want to be very loud and proud about this project and say, I did this project. But then it should have a logical flow. Your scope cannot say X and your output cannot be Y, right? So think about that. And that's why I say this is a living document. It is quite likely that when you get on to assignment 3, you say that, oh my God, I think I need to change the scope. So yes, go back and see what you need to do. That's why I don't want you to go back a lot, because then you would probably have to, go back and mark and change so many sections, which I don't want you to do. In the interest of time, try not to steer away from what you started with. But if you have to, you have a way to kind of go back and change this. Now, there are going to be always minor things that would come up that you would say, okay, and that's why I say executive summary is a classic case of being a one of the sections that you could keep refining it every time you go to it, said, okay, I put this in, but you know what, I need to add this now in my executive summary, or I need to change this, or I need to remove this because my summary has gone too long, right? So again, there are things that you have to start building on, and that's one point. It's a living document. Number two is to not get ahead of yourselves. What I mean is, if you are in the data exploration part, just remain there, because if you step ahead and start thinking about or writing about data model, or how about how your modeling technique and all that, then you really stepped ahead and started to work on something that this particular time it's not talking about, this section is not talking about. So when you are reading this, just spend some time reading on your assignment and saying, okay, does it have a very good flow? If someone is going to read this, does it going to get exactly what this project is about, how I've gone through it, what I've explored, what data set it is, what kind of variables it is, and what am I leading to? So, give it to someone, give it this to your friend and say, okay, hey, read this. Does it make sense to you? Do you understand? That's one of the easiest thing you can do, and that's how easily you can find out if you are doing a good job with putting up this project report. Okay, so So these are two very, very important points I wanted to mention. And third, third important point, being a project report, use all those, things that you've learned in the past about writing a paper, right? Make it like, I don't want you to be like double spaced, at 1.5 lines is good. Have a consistent spacing, use your APA format. Once you've written a particular section and it's complete, and there's nothing more that you're going to add, for that particular assignment, remove those red placeholders. Those placeholders are all these things in red are there to guide you, to help you what needs to go into the section. But then once you're done, you can just remove it, because at the end, it should really look like a report that you can carry with you for your interviews, or for telling people, or presenting it to someone, presenting it to your friends, or whatever that is. That's how you want to think about this project report. Okay. So you went through project scope, you went through data exploration, and next is data visualization. This is where you're going to do all your statistical analysis, your descriptive statistics will all univariate, bivariate analysis that you probably read about in week 3, and some, yeah, most of it in week 3 you did that. You're going to do all your visual data visualizations. You're going to put up some visuals out there. That's going to be your 3, and that's the assignment 3, which is very important. Like, don't think of just doing blindly, just doing all the visualizations. Think of what visualizations are really going to help you, right? I'm not saying do the bare minimum. I'm not saying, but at the same time, I'm not saying that if you have like 25 variables, do like a univariate analysis on all 25 variables. That doesn't make sense. I'm not looking for all 25 charts here. But what is really important, right? What is the target variable, maybe univariate analysis on that, or how is it connected to certain, with certain variables. All those kind of things that comes into your mind when you're going through the data, that should be a data visualization. Okay. So very important, because I've seen, the past, someone has kind of said that, oh, there are 15 fields, or there are 15 charts there for each variable. I'm like, okay, tell me, why did you come up with 15 charts? What was it like? If you probably used it, fine, but would you put it in a report? What are you going to tell me? What is this chart telling me? What value does it add to your report? So question yourself when you're adding anything on this report, right? Okay. And then you have assignment 4. Right, what happened to my, this is assignment 4. I'm sorry, it shouldn't be 5. Assignment 4 is data modeling, right? So you're getting very close to that. And that's why I kind of covered what I just covered about, modeling. Like, again, think about everything that you've learned, and create, a couple of models or even more, right? Again, I'm just saying, there's results of 2 predictive models, but maybe you would have created 50 models and then said, okay, I'll take my best 2 models and I'm going to talk about it. And that's good enough, right? Or if you want like 3 models max, right, that were very close to each other, and you really, really want to talk about, fine. But again, don't talk about all the 40 models that you would have created, right? Doesn't make sense. It's not going to add any value. But so, think on those lines as well. Don't just add things for the sake of. Again, same logic here. And then talk about your both the models, talk about what you review it, why do you think it's your champion model, it's your best model, and if you are able to interpret your model, right? That's why I went through the interpretation. That's going to be huge, because you're going to write about your model. And if you know your model well, if you know the interpretation, if you know what solution it is, then you're going beyond being a solution provider. You're not just any other technologist. You're now acting as a data scientist to say, hey, this model is this, it is doing this, and all of that. So you're not just telling me about the configuration and all that stuff, all the technical stuff. You're telling me more about it. And that's when all this Lime and Sharp and whatever you want to do to ensure that you clearly understand what your model is doing and why you picked that model. Okay. So that's your assignment 4. And then your assignment 5 is a culmination of that, right? You're going to be, you know, about your findings, about your success or completion, evaluating your execution of the project, your potential data privacy and data security issues that can occur in your data set, how you could enhance it for recommendation for your future analysis. So that will come into your final week, right? But again, don't step ahead. Right now, just be in the present. Try to see what's needed every step and start building it. Trust me, by the time, if you've gone through these steps correctly and time and being in the present, you would be, when you get to the final, weeks, you would be pretty much through it with what material or what information you want to put it here. It would just flow through well. You would have all that information. Okay. And again, don't forget, for every assignment, you are completing these sections. Like some of you either just cut out this section or put in one-liners, and I've kind of given that feedback. One of the reasons why I've gone a little slower, kind of grading your assignment. You may have noticed that, especially if you've been with me in the previous class, I've been a little slow to kind of give you that comprehensive feedback. I want to probably do the same in assignment 2. I'm going to do that, but I know there's a lot there, because for 18 of you, that means 18 times 2 is 36 paper. But I'm trying to give you some good feedback that you want to apply for your future assignments. So if I given you a feedback that, hey, this probably is not right, or work on your project scope, or work on this, make sure you work on it. Because if you're just going to keep the same as, it's done, it's over, my grading is done, I don't need to, but again, it's not going to flow well. There's a reason why I've given you a comprehensive feedback, so you can go back, change it, or do or make all the modification, and then come to your assignment on hand. Okay. So your completion history, your lessons learned, very important for every section. Again, I'm not looking for a full 1-page or a story for each of the weeks, or weeks 1 and 2, or for every assignment, but yeah, just a short paragraph of what what did you complete, how did you complete, and what have you learned, right? And most importantly, you have your assignments rubric there. Take a look at the rubric and see what, or how is it being graded. Have you completed what was being required from you, right? What is expected from you? Okay. Make sense? Any questions?
I have some more like questions about the assignments that I can handle after
Sure.
classes.
Sure, go ahead.
Um, for me, like because I'm doing a CNN and trying to like come up with this convolution around that, there's a lot of things that don't line up with like the assignments. Like trying to do a data summary is basically just repeating the background section. So I was wondering if there's ways that I could like kind of work around that to use the CNN architect, but like for like the assignment 2, instead of using a data summary, maybe doing like a CNN model summary, so I could go through like the different layers that I'm going to be adding in or something like that.
See, that will come in your assignment 4 when you're going to be talking about the model. So step back and think of, before even going to your modeling phase, it is talking about your data, right? What is your data? So that's why I said, do not, get ahead of yourself, because then if you start writing about your model in your data exploration, then you will not have much to talk about in your modeling section, which is your assignment 4. So let assignment 4 handle, or that particular week you would be talking more about your model. But then in this sections, in the earlier sections, you are just talking about the data set on hand. Just focus on the data set. Like, what is the data set bringing in, or what are the variables and all of that. Does that help, Sheldon? Did I answer your question?
Not really. Maybe I need to set up like a special time to kind of go over all of this stuff just
Sure.
with you after.
Okay, yeah, we can do that. Not a problem. Okay, any other questions? I know, Chase, you had a question on your assignment too. Was it a very similar one to Selden, or is it a little different?
Yeah. I think I'll, in terms of all the concerns related to my idea and deliverables, like if I could just have some time for you after the Zoom call to
Okay,
kind of
okay,
explain what I'm working on
sure.
and get your approval on it.
Okay, okay, very good.
Yeah.
Yeah, we'll certainly talk about that. Okay. Any other questions? Any general questions? Okay. All right. So I'll go on to, again, reminding you, since this is another discussion week as well, I wanted to remind you about all these four of aspects of discussion that I'm looking for, and you got feedback on it as well. So ensure you're posting by Saturday. That's very important. Um, ensure that you're commenting to two of your classmates at least. Respond to any questions from me or comments from me, or just acknowledge, right, for your initial posting. If somebody had said something about it, then please acknowledge it in some way. If there's a question, answer it. If there's no question, at least say, hey, thanks for your feedback, blah blah blah, right? Just even just a very short message back is important, right? And if you posted it late, or you've not got any comments from anyone, then simply go and comment it on your own post as like an enhancement to it, not less just as and kind of explained this to earlier. But think of all these four aspects for discussions, that which is going to fetch you or get you the maximum points, right? So please, it's not difficult, and I hope you can all strive for and work towards getting full points for your discussions. Okay, any questions on discussions in general? Okay, very good. So just showing you that you're now kind of working on, you're in the fourth week, and very soon, yeah, by the time we meet next time, you will be pretty much in the sixth week that time. So these are the weeks that you'd be working on your assignment 3. You'd be working on, you'd be kind of doing a little prep for your assignment 4. And then, by the time we meet, you could be, I'm sorry, you would be, yeah, we'd be ready to kind of present or submit your assignment 4 along with discussion 3. That's where you would be when we meet the next time. Okay. So again, just showing you where we are currently. We finished. We had a course introduction webinar. We had weeks 1 and 2 webinar. We are at the week 3 and 4, and the next one we'll be meeting again on the 23rd this month. Okay. So again, I'll send it out, and I won't forget to put a reminder in the classroom as well. So I've been doing it. For some reason, I missed that completely today. But I send out the email by Monday or Tuesday. So I hope you are also seeing or just checking your emails on a daily basis. All right, you know about the late policy. Just putting it up here. Don't want to deduct any points for anyone, but please, if you are getting into any hardship or any challenges to submit it, I understand. But again, don't stretch this too far. This course is different than the other courses. So missing out on any assignment or being late, even when later than what your accommodation, if you have accommodations, I understand, and I'm kind of very much oblivious of that. I'm take that into consideration, but there would still be late policy that could be applied. So please don't wait. This is a very different kind of a course where your each assignment is building to on your report. So it would be too much to kind of do a lot at the end. Okay, so just letting you know. And just having the slide up here, in case you need to reach me, this, but I just have it here in case you need to kind of look at it or know where to or who to connect. Okay. With that, I'm pretty much done with what I wanted to cover, but any other questions in mind? Any general questions, assignment questions, course related, or anything outside? Okay, if not, then I'm going to call it a wrap. And Chase, you can stay on and we can talk about the question you have. And Sheldon, please let me know when you want to meet next, and Bill can try to have like a quick session or a phone call. Okay, the time of your convenience.
I'm still here. I can wait.
Okay,
If that's okay with you. I can do like a share screen thing so you can see what I'm trying to. I'm trying
sure,
to get like the full thought through. So
sure. Chase, would you be okay to have Sheldon around while you're talking through your problem?
I actually gotta go use the. I'm gonna go use the bathroom quickly. So Selden can go take care of
Okay,
whatever he needs to ask first,
okay,
and then I'll just wait because I know
okay,
I want to make sure I get all my the everything that I kind of have prepared for my plan B to present to you, since it's really just gonna be a whole new project altogether. So
okay. We'll talk about it then. All right.
yeah, yeah,
So,
I'll hang on, but
all right.
Selden, go ahead and go first. I'll be right back.
Excellent. So thank you, and thank you, Meg, for being here. And feel free to be here again if you want to, but otherwise we're done for the day. And I'm going to just shut down the recording here. Okay. Thank you.
All right. Thank you. Have a good night.
Good night.
okay. So